Welcome back, dear students. Hope you would have understood HCF and LCM by the prime factorization method, which we have discussed in the previous videos. And in this video, I am going to discuss HCF by long division method or Euclid's division algorithm. Most of the students are confused between algorithm and lemma. Lemma is used for word problems and algorithm is used to find out the HCF by long division method. Now before we start with the Euclid's division algorithm, there are a few important points which I want you to understand. Now in previous classes we must have studied the division. In actual division you would place a decimal over here and get the answer as a remainder as 0. But in this one particular, we want the quotient to be always in terms of whole numbers. It should not be in fraction or decimal or any mixed fraction. So in this method, what we are doing is we are dividing 7 by 3, hence the quotient becomes 2 and the remainder is 1. So there will be some remainder. Right? At one stage it can be 0, but now it is there. So we will rewrite it as P of x is G of x into Q of x plus R of x. Right? So let's say P of x is 7 because you are dividing it by 3, so the divisor is 3, the quotient is 2 and the remainder is 1. Hence, so this is the main thing, that whenever you divide by 7 by 3, the result is 2, that is the quotient, and the remainder is 1. This is the concept that we will be using to find out the HCF of two numbers. If you remember, in the last example by prime factorization, I have told you that we will do the same example for the division algorithm so that you can verify that whatever the case, whatever the type we do choose for the solving of one particular question, the result is always the same. So we will take the HCF of 135 and 225. So first of all, we are doing it by prime factorization. This will be 3, this will be 45, this will be 3, this will be 15, this will be 3, this will be 5, this is 5 and this is 1. This is 3, this is 7, 5, this is 3, this is 25, this is 5, this is 5 and this is 5 and this is 1. So we can say that it is 3 cube into 5 and this is 3 square into 5 square. So the HCF should be 3 square into 5, that is 45. So the HCF of these two numbers by prime factorization method is 45. Right, you can take a screenshot. We will proceed with the same example for division algorithm and see whether the answer will be 5 or not. $135 and 225. This is 225. This is 135. We divided by 1. This is 135. This is 90. Now among these two, 90 is smallest. We will take it inside 135, 190, 45. Among these two, 90 is smallest. So we will take 90 to 90, the remainder is 0. Now this is a very crucial step. The point where the remainder becomes 0, the divisor should be the HCF. Right? So divisor is HCF when the remainder is 0. Or you can also write it in this form. 225 can be written as 135 into 1 plus 90. Then 135 can be written as 90 into 1 plus 45. And 90 will be written as 45 into 2 plus 0. Right. So from the board examination point of view, you can write it with this. This is long division method. Now we'll take up another topic over there and we will conclude HCF and LCM. You can take a screenshot, you can see how we have written this. First of all, we'll start with the checking which of the number is smallest. The smallest number will come outside with the divisor and this will be dividend. So then we'll divide it accordingly and we'll get the result as 0. Now let's take another example. $32 and 45. Again, this is smallest and this is one largest among them. So 32, 45, 1, 32. This will be 13 and 32. This will be 2. That is 26. This will be 6. 13 to 12, this is 1. You take 6, 6, 6, 0. So the HCF is 1. Right. So if I told you earlier, if they don't have any common factor, the HCF will come out to be 1. And this is also, you can find out the HCF being 1 by long division method. Right. Hope you have understood it and you would have taken a screenshot. Now we'll proceed to the next one, where we'll say that HCF into LCM is product of the numbers. Right. So again, we'll take 35 and 30 and 36. The HCF is 6. One of the values will be given to you in the question. If HCF of 30 and 36 is 6, find the LCM. So we'll write 6 into LCM will be 30 into 36, then 6 divided by 6, this is 6, so the LCM comes out to be 180. Right, this is also one of the ways to find it out. Right. And if, let's say, we have given out the LCM and HCF of 45 and 60, so we'll divide it with that. We'll take another example, that LCM of 45 and 60 is 180. LCM of 45 and 60 is 180. Find the HCF. So again we'll say LCM into HCF is product of the given numbers. So LCM is 180 into HCF, this is 45 into 60. So HCF is 45 into 60 divided by 180. So the HCF comes out to be 50. So by this method you can also find out the HCF or LCM if one of the values is given to you. I hope you would have understood it. Thanks for liking the videos. Thank you so much.